EHang 216. Designed by the Chinese manufacturer EHang, the EHang 216 is a two-seater autonomous electric vertical takeoff and landing aircraft that is also referred to as the EH216S. Urban air mobility is the focus of this pilotless passenger-carrying unmanned aerial vehicle system, which demonstrates cutting-edge technology. The pricing of the EH216S is $410,000 for markets across the world that are not located in China. The suggested retail price in China is 2.39 million yuan, which is equivalent to around $338,000 in American currency. The EHang EH216S is priced strategically to effectively penetrate the market, and it provides an option that is priced more affordably in comparison to the ideas that were made earlier. This pricing reflects EHang's intention to make autonomous aerial transport more affordable and realistic, hence advancing the likelihood that electric vertical takeoff and landing technology will be commercially possible. Flying Train Dahir Insat. The Flying Train by Dahir Insat is a concept for transportation that was conceived by the Russian engineering company Dahir Insat. It is a futuristic transportation system. This cutting-edge system combines elements of conventional rail travel with cutting-edge technology, and it is comprised of train-like pods that are suspended from above lines. Although the pods are meant to move at high speeds, they offer an alternative that is both quick and efficient in comparison to traditional trains and urban transportation. As a result of its electric propulsion, the system claims to minimize the amount of traffic congestion and provide benefits to the environment. Additionally, the elevated rails allow for minimal interruption to the infrastructure that is already in place, which makes it a solution that is both adaptive and scalable for contemporary urban landscape developments. Renault Float. An innovative concept car that blends cutting-edge technology with a future design, the Renault Float in motion is a vehicle that mixes the two technologies. Due to the fact that it has a distinctive spherical shape, it is able to move in any direction without any difficulty. The outside of the car is constructed out of a material that is translucent and has the ability to change color and transparency, which provides an appearance that is both dynamic and adaptable. On the inside, it features a roomy cabin that can be customized to your preferences with an emphasis on comfort and connectivity. Float in Motion is a vehicle that is built for autonomous driving and is outfitted with cutting-edge sensors and artificial intelligence to provide a ride that is both safe and efficient. It exemplifies Renault's vision for the future of urban mobility, which places an emphasis on user experience, flexibility, and environmental responsibility. SkyWay Technology Advantages. SkyWay technology presents numerous advantages, particularly its cost-effectiveness. One of the primary benefits is its considerably lower construction cost compared to traditional and advanced transit systems. For example, SkyWay integrates innovative transport infrastructure at a fraction of the cost associated with more conventional systems. This involves significantly lower requirements for steel and reinforced concrete, optimizing material use while maintaining structural integrity. In terms of transportation costs, SkyWay boasts significantly lower figures when compared to rail, automobile, and magnetic suspension trains, achieving up to an 1,800% cost reduction over traditional monorail systems. The total estimated cost for projects like SkyWay is around $300 million, exemplified by a specific project mentioned in the Miami Herald. Additionally, SkyWay's implementation requires minimal leveling or mountain drilling. Gyroscopic transport. In his vision for the future of urban transportation, gyroscopic transport, Dahir Insat aims to completely alter the way people navigate through cities. These solar-powered, disc-shaped cars use flywheels to float above traffic on stilts. Their multi-tiered transportation system has the ability to lessen pollution and traffic jams. Travelers can anticipate either cramped, subway-style seats or plush pods outfitted with sofas and televisions. Although the specific cost has not been made public, the idea's positive effects on the economy and the environment indicate that it may prove to be an economical choice for urban areas in the future. The design prioritizes user comfort and integration with urban settings, with the possibility of working in tandem with pedestrian spaces. This groundbreaking form of transportation is still in its early stages, but it has the potential to revolutionize urban transportation in a sustainable and efficient way. NASA's CAPSTONE. The small CubeSat mission called CAPSTONE, which stands for Cislunar Autonomous Positioning System Technology Operations and Navigation Experiment, is launched by the National Aeronautics and Space Administration to verify and assess navigation systems and lunar orbit dynamics that are vital to the Artemis program. Approximately $30 million was spent on developing the CAPSTONE spacecraft, which is roughly the size of a microwave oven. The mission's development cost $13.7 million, with an extra $9.95 million going toward the launch. Rocket Lab's new launch pad in Virginia allowed the mission to take off thanks to the launch contract that NASA granted to the company. Both NASA and taxpayers have benefited from the mission's use of fixed-cost contracts, which have effectively reduced costs. For the Lunar Gateway and subsequent trips to the Moon, the CAPSTONE mission will serve as a demonstration of a precise. NASA HAVOC. NASA's high-altitude Venus operational concept explores the feasibility of human exploration of Venus. HAVOC envisions an evolutionary exploration plan, focusing on the atmospheric conditions of Venus, which present a more manageable environment compared to its hostile surface. The concept includes using crewed airships to float in Venus's upper atmosphere, where conditions are more Earth-like, enabling scientific research and potential future colonization. A detailed study on this atmospheric habitat was conducted by Dale Arney and Chris Jones at NASA's Langley Research Center. Various models and artworks related to HAVOC are available, such as a 3D model of the HAVOC crew transfer vehicle, priced at around $35, with discounted offers available. Additionally, a softcover publication on HAVOC was listed at $134.75. Artworks related to HAVOC missions can also be found, priced at $15. Star Raker. In 1979, Rockwell International began developing the Star Raker, a spaceship that would carry heavy payload and go from stage 1 to orbit. Using a combination of ramjets and rockets, this remarkable winged orbital launch vehicle was engineered to land horizontally and take off horizontally. The Star Raker was an ambitious spacecraft that hoped to drastically cut the anticipated $22 to $33 cost per kilogram of payload to orbit in 1978, hence reshaping the space transportation industry. The intricate design, which had 225 pieces, had proportions of 22 by 66 meters and had the potential to be cost-efficient. The Star Raker had a useful purpose as a spacecraft, but it also served as the basis for many fictional representations and replicas. The Star Raker is an important character in stories about space travel, both real and imagined, because of its ingenious aircraft engineering and its cultural impact. Kelekona's Colossal. The New York City firm Kelekona is planning a massive electric vertical takeoff and landing plane that can carry 40 people. This daring plane can travel fast between cities and can accommodate 40 people. Every part of the plane works together to create lift. Unlike any other plane, its fuselage is unusually oblong and narrows towards the back. In order to achieve vertical takeoff, the plane makes use of 4 sets of 2 huge ducted fans equipped with variable pitch blades. According to its claims, it can cover the 330 miles between Los Angeles and San Francisco in under an hour. A massive detachable battery pack with 3.6 megawatt-hours of power powers the plane. Thanks to the aircraft's removable battery pack, it may continue to its next location, even as the battery is being recharged. As far as public transit strategies go, this fresh take on eVTOL design is unprecedented. Plana eVTOL aircraft. A South Korean firm called Plana Aero is working on a CP-01, a hybrid electric vertical takeoff and landing plane. They hope to make regional air travel more accessible with their hybrid air taxi, which has an impressive range of up to 500 kilometers and is priced affordably. This will revolutionize urban air mobility. When compared to completely electric vehicles, Plana's hybrid propulsion system improves fuel economy and increases range. If all goes according to plan, the business will supply SkyTaxi with 10 CP-01 planes by 2030 and another 40 by 2040. It is said that Plana is trying to make it cost-effective by scaling manufacturing in an effort to bring the price down to $3.5 million. However, the precise current pricing is not disclosed. Plana is aiming high with its ambitious objectives, which include creating full-scale prototypes and achieving mass manufacturing with the help of substantial fundraising. Bellwether eVTOL. An innovative electric vertical takeoff and landing aircraft developed for use in urban areas, the Bellwether eVTOL is popularly known as Volar. Its wingless lifting body and concealed propulsion mechanism make it an excellent choice for urban settings. Redefining intracity mobility, the Volar is small, eco-friendly, and provides a smooth transition between ground and air travel. The third-generation Volar, the Oryx, offers enhanced flight efficiency and reliable performance in complicated urban environments, thanks to innovations in airframe design and flight control technology. The Oryx exemplifies Bellwether's dedication to developing innovative aircraft with a focus on human needs. It can accommodate 3 people and measures 3,700 by 6,300 by 1,900 millimeters. The price tag will likely start in the 7 figures, but as manufacturing gets more efficient and scales up, the hope is that it will converge with the cost of owning a car. Transit Elevated Bus. This forward-thinking public transportation concept, known as the Transit Elevated Bus, was developed with the intention of reducing the amount of congestion that occurs in urban areas. Cars are able to travel underneath the TB because it is raised, which allows it to glide above the road on fixed rails. It is supported by solid stilts on either side of the road, giving it the appearance of a moving tunnel underneath the road. As a result of the bus's capacity to transport up to 1,200 passengers, the number of vehicles on the road is reduced, which in turn greatly reduces the number of instances of traffic congestion. Due to the fact that it is powered by electricity, it is an environmentally beneficial alternative. Using existing roadways without requiring substantial infrastructure upgrades, the TEB is able to move smoothly above traffic at speeds of up to 40 miles per hour, making it a method of transportation that is both speedy and efficient. Next, future transportation. A new way of thinking about urban transportation is proposed by Next Future Transportation. A scalable, adaptable, and modular transportation system, it was created with these qualities in mind. The plan is to have self-driving electric pods that can navigate normal roadways and, if necessary, link up with other pods to create a bus-like structure, enabling riders to transfer between pods without getting out. Environmental friendliness, fewer traffic, and a more pleasant travel experience are all goals of the system's designers. Because of its modular design, Next can adjust to meet the needs of many cities and between them, which could revolutionize public transportation. Despite the lack of publicly available information regarding the Next system's price, the business has managed to gather $2.6 million in financing, showing a great deal of enthusiasm in turning this ambitious vision for the future into a reality. Virgin Hyperloop. By rapidly pushing passenger or freight pods via near-vacuum tubes, Virgin Hyperloop intends to transform transportation. By combining electric power with magnetic levitation, these pods have the ability to travel at speeds of up to 670 miles per hour, drastically cutting down on travel time between cities. The goal of Virgin Hyperloop is to reduce the normally 6-hour drive time between San Francisco and Los Angeles to 30 minutes. The business's ultimate goal is to create a safe, efficient, and environmentally friendly transportation option that significantly reduces travel time and pollution. As the system is still in the planning phase, actual passenger pricing is not yet available. However, estimations indicate that it might be priced competitively with current airfare and high-speed rail options. Regulatory clearances and the effective deployment of the technology are prerequisites for the anticipated launch of passenger services in the 2030s. Future fire truck concept. When it comes to rescue vehicles, Dahir Insat's future fire truck concept is state-of-the-art. With its gyroscopic stabilization system, this concept truck can extend its legs and drive across traffic, lowering response times in crowded locations, making it ideal for navigating busy urban conditions. For effective firefighting, the design has numerous high-pressure nozzles that can be controlled remotely for added safety and accuracy. Although there are many novel aspects to the idea, no concrete facts regarding the cost are available at this time, since it is still in the prototype stage and not a finished product. The idea behind Dahir Insat isn't to provide a vehicle that's ready for sale, but rather to highlight possible innovations in firefighting technology. Consequently, the cost of production, the demand in the market, and the state of technology at the time of possible manufacture are all variables that would affect the price.